So since we're looking at number bases for systems from 2 up to 16, so we're going to start with base 2, right? We're going to start with base 2. So we know that base 2 has only two digits, 0 and 1, okay? So we're going to look at base numbers from base 2 up to base 16. Of course, the popular ones are base 16, base 8, and base 10. Base 10 is what we are using now. Lah. So the popular systems are 2, 8, 10, 16. Okay, all this we must know. Okay, the rest also, once you know the overall formula, you know how to do any base. Okay, so supposing you are given base 7 numbers. How many digits are there in base 7 numbers? Anyone?
7.
7 digits, huh? Yes, 7 digits. That is digits from 0 up to 6. Huh? So if you have base 9, so the digits will be 0 up to
8.
8. Correct. So what about base 11?
0 to 10.
Yes, 0 to 10. Base 12? Sorry, base 11 is not 0 to 10, because our digits are only 0 to 9. Base 11 is 0 to 9. Our 10, we don't write here 10, but we use alphabet. So the next alphabet is A. So this A actually represents 10. So base 12 will be 0 to 9. For our 10 is A, 11, correct?
B.
AB, yeah. So base 13 will be 0 to 9, and then A, B, and C, because A is 10, 11, and 12, okay? Base 14 is 0 to 9, A, B, C, and D. Base 15 will be 0 to 9, A, B, C, D, and E, okay? And base 16 is 0 to 9, and we have A, B, C, D, E, F. A represents 10, B represents 11, C is 12, D is 13, E is 14, and F is 15. Okay, so because our digits are only until 9, we only have 9 digits. Okay, so so because of that, to overcome this problem, we continue with alphabets. Okay, so that's the difference in the symbols and digits for base 2 up to 16. Until 9, there's no problem. Okay, if it's base 9, we have 9 digits, but the digits are only until number 8. If it's base 6, digits are until number 5 only. Okay, so these are the symbols and the digits. Okay, let's look at this table first. See, this is a base 10 table. Okay, so we start, this is our normal decimal system, so we already know this. So 0, 1 until 10. After 10 is 11, 12 until 20, then 30 onwards. Okay, for base 2, there's only two digits, 0 and 1. So all numbers, base 2 numbers only consist of two digits. So after 0, 1, after 1 is 10, and then it's 11. Do you understand how to write these numbers? You see, it's 0 and it's 1. So after 1, you go back to 0 and 8. So you see, it's like this. Base 2 numbers. Okay, so base 2, the place value is 2 to the power of 0, to the power of 1, 2 to the power of 2, to the power of 3, and so on, right? So this is when the first number will be 0. Okay, when you want to add one more, here we can add 0. Okay, when you want to add 1, when you add, sorry, so this is 1 meter, so 0, and also 1 is here. When you want to add one more, when you add one more, 1 to 1, it becomes 2. So you can't write 2 here. So 2 has to go to the next place value. So the next number becomes 1, 0. Okay, so then when you add another 1 here, it becomes 1, 1. Okay, and then when you add another one more, okay, it moves it moves to the next place value. So this becomes 1, 0, 0. The next number is 1, 0, 1. Okay, then 1, 1, 110, and then 111, and so forth. Okay, so this is how we write the numbers. We use the place value chart. We keep on moving place values. Okay, so for base 10 we have digits 0, 1, 2, 3, 4, 5, 6, 7. There is no digit 8, so we cannot write anything 8 and above. Okay, so we cannot use digit 8, we cannot use digit 9. So after 8 and 9, the next number is, after 7, we go back here and we start again. 1, 1, 1, 0, 1, 1, 1, 2, 1, 3, and so on. So we have 11, 12, 13, 14, 15, 16, 17. We cannot write 18 because 18 has an 8 digits. We cannot write 19. Okay, so the next number after that will be 2, 0. Okay, then 21, 22, 23, 24 until 27, 28 we cannot write anymore, 29 cannot, then we continue with 30. Can you understand that?
Yes.
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 For base 6, let's say for base 6, so we start with 0, 1, 2, 3, 4, 5, 6. We cannot write already. We can't use 6, 7, 8, 9 cannot be used. Then we go back and we continue here, 1 again. So it becomes 1, 0. This is not 10, actually it's 1, 0. 11, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 cannot already. 1, 7, 1, 8, 1, 9 cannot. And then we go back and becomes 2, 0. Okay, then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 cannot, 2, 7, 8, 9 cannot, then continue with 3, 0. Okay, can you understand that? So for
Yes.
base 16, it is 0 until 9, and then A, B, C, D, E, F. After F, what's the number?
10.
Yes, 1, 0, and then until 1, 9. After 1, 9, what do you have?
1A.
1A, correct. 1A, 1B until 1F. After 1F,
20.
yes, after 1F, we continue with 20. Okay. If you can see that clearly, then it's very good already. Okay. So you need to know how to write these base numbers. Okay. The other thing that you need to know is you need to understand what these base numbers mean. Okay. Using concrete manipulatives. Okay. So how do we represent base, say base 2 numbers? So it is 2 to the power of 0. This is 2 to the power of 0. Okay. 2 to the power of 0 is actually 1 is 1 cube. 2 to the power of 1 represents two cubes. 2 to the power of 2 is 2 of 2, okay? 2 cubes. So it's 4. 2 to the power is 3 is, we have 2 fours here, is 8. Okay? 2 to the power of 4 is 16, and so on. So these concretely represents base 2 numbers. So we can see like 2 to the power of 6 is 64. But in 64, we can see two sets of 2 to the power of 5, or two sets of 32. Okay, in 32, there are actually four sets of 2 to the 16th. There are two sets of 16ths of four sets of 8. Okay, this is how we represent numbers concretely. Okay, so if we were looking at base 5, okay, if we want to express base 5 concretely, this is how we would express base 5. This will be the ones, okay, ones, 5s, 25s, and what is this? How much is that?
125.
Yeah, 125. So we can see that one fives here, it consists of 5 ones, okay? 125 actually consists of 5 5s. So if you have 5 5s, you can combine it to 125. If you have 5 25s, you can combine it to 125. So what does this number represent in this diagram? What number do we have here? So we have 1, 1, 3, 2. So this number is actually written as 1132, and we write a subscript 5 here to show the base. If we were to write a number like this without writing any subscript, that means this number is a decimal number, base 10. Okay, base 10, we don't have to write any subscript to show the base. Okay, if you want to show the, if it's a base number, then you must write the base at the bottom here. Okay, so if they asked you what is this, how can you represent this number concretely, this is how you will show it. Okay, so you need to know that this is 5 to the power of 0, place value 5 to the power of 1, 5 to the power of 2, 5 to the power of 3. It means there are 2 1s, there are 3 5s, 125 and 125. Okay, so this is just to understand the concept of base numbers. Okay, this is another example here. Okay, we're using concrete manipulative to represent base 5 numbers. If the number is 111 base 5, it means there is 1 1s, 1 5s, and 125s. This is how we represent the number. Okay, if we had 263 base 5, we have 2 25s here, 6 5s, and 3 1s. Okay, if the number is 122 base 5, then we had 125, 2 5s, and 2 1s. Okay, 101 base 5, 125, no 5s, and 0 1s. Okay, okay. How about base 8 numbers? Okay, base 8, we start with 8 to the power 0, 8 to the power 1, 8 to the power 2. So this number 111 base 8 will actually mean there is 164s here, 1 8, and 3 1s. Okay, and if we had 245 eights, it means there's 265s, 4 8s, and 5 1s. Okay, for a decimal number, if this was a decimal number base 10, then this is actually the ones column, this is the tens column, and this is represents the hundreds. Okay, so here we don't have tens, but we have eights because it's base 8. So our second column is according to the base, it's only 8. So if we calculate here, there is only 8 units in each 8. Okay, and 130 base 8 is, okay. Now let's just look at how to represent addition of base numbers using concrete manipulatives. So if you had two numbers like this for addition, you always represent both numbers first. So we have 433 base 5, 4 25s, 3 5s, and 3 1s. We represent, this is the first number, and then represent the second number, 4 5s and 4 1s. Okay, now we add together. Add means we bring it together. Okay, we bring it together. Okay, okay, bring it together. So we have 4 25s, 4 25s. These 3 5s combine with these 2 5s to make another 25. So we have 2 5s remainder, and we have these 3 1s here combined with these 2 1s to make a new 5s. So our final answer is we have 4 25s. We have 5 25s, 3 5s, and 2 1s. So our answer is 532 base 5. Okay. So if you're asked to do the addition using algorithm, you can do the normal way. if you are asked to show the concept of addition, this we're showing the concept of addition of base 5 numbers, then this is how you must show it, because you need to understand that this 5 represents a 25 piece, this one represents a 5, and this one represents ones. Okay. Similarly, if you're doing subtraction, also same method. But for subtraction, you don't have to represent both numbers. You only represent the bigger number. Okay, the larger of the two numbers. You represent 243 base 8. So 264s, 4 8s, and 3 1s. You represent this number only, first number. Then you take away the second number from what you have represented. Okay, so you want to take away 127 base 8. So you want to take away 164. Okay, so you want to take away 164, throw this away. You want to take away 2 8s, throw these two away, and you want to take away 7 1s. Okay, throw these 7 1s away. So what is left is 164, 1 8, and another 4 1s. Okay, so this minus this will give you this answer. Okay, this is how we show or demonstrate addition and subtraction using concrete materials. Okay, it's just an example for you now. Okay. 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 The next thing that we're going to look at is we're going to look at how to count using base 10, number bases. So supposing you had, say you were given 10 concrete blocks here, okay? So you have 10 cubes here, and you want to count in base 2. You want to use base 2 and count. You know that base 2 you group in twos, okay? So you have one group of twos, two group of twos, 3, 4, and 5. So we have 5 groups of twos here. So how are we going to write our numbers? Our base 2 numbers is like this, okay? And so on, okay? So we have ones here, twos here, fours, eights, and so on, okay? So if we have 5 groups of twos, okay? So this is our twos, but we can't write 5 because we can't use the digit 5, okay? So even if you want to group these twos as 4 and 4, we can't write here 2 because we can't use the digit 2. So we have 4 groups of twos, which is 8. So we have 1 8 here, and we have a balanced twos, which is 1 twos. Okay, we have 1 twos here. So the rest is 0. So this is our number 1010 base 2. Okay, if we want to use base 3, so we want to group these numbers in threes. Okay, so we have 3 groups of threes, and we have one ones, threes, nines, 27s, and so on. Okay, so we have 3 groups of threes, but we can't write 3 here, so we take 1 9 here, 1 9, and we have 1 1 here. So this is the number. Okay, so if we want to write base 4, we group it in fours. Okay, 1 2. So we have 4 groups of 4, and we have 2s there. So we have 1s, 4s, 16s, and so on. Okay, so we have 2 groups of 4s. So 4, we can write here 2 because 4, we can use up to digit 3. So we can write here 2. And we have a balance of 2 1s there. So we write this 2. So this is 2, 2 base 4. Okay, so if we had base 5, okay, so 5, we have 1 groups of 5 here, and we have another group of 5 here, 2 groups. Okay, so we have ones and we have fives. We have 2 groups of 5, which is 0, 2, and ones we have, there's no ones here, remainder, so the number is 20 base 5. Okay, if we had base 6, then we would group as one group of 6, remainder 4, not enough to form another group. So we have ones and sixes. We have one group of 6 and we have remainder 4, so 4 ones. So this is 1 4 base 6. Okay, and one more last example. Okay, let's say we're doing base 7. So we have one group of 7 and we have remainder 3. Okay, so we have one group of 7, remainder 3. This is 13 base 7. Okay, this is how we can count in base numbers, count concrete objects in base numbers. Okay, any questions?
No.
Okay. Okay, now we're moving on to arithmetic. When we do number bases, okay, arithmetic is an important subtopic. Okay, so we need to know how to add and subtract in different number bases. Okay, so let's do, I'm sure you already looked through this already. Yeah, base 2. Okay, we're going to do base 2 addition and subtraction. Okay, let's go straight to examples. So supposing you wanted to add these two numbers, 1 1 0 1 0 0 1 1 1 base 2, add 1 0 1 0 1 1 1. Okay, what are the rules of addition that you already know? 0 plus 0 is equals to
0.
1 plus 0,
1.
0 plus 1,
1. 1.
1 plus 1,
1 0.
1 0, correct. Okay, so 1 plus 1 is 1 0. So it's 0 and we regroup 1 up here. So 1 plus 1 is 1 0 0 1. So what do we have here?
1.
You can add this if you want. Okay, so 1 plus 1 is 1 0 plus 1 is 1 1. So 1 1. Okay, so if we group 1, we have 1 here, 1 1 plus 1 0 1 1 0, so 0 1 1 0 0 1 0 1. So this is the answer. Okay, correct. Any problems with addition of base 2?
No.
Okay, subtraction. Okay, subtraction 0 minus 1. Okay, so cannot minus. So we are going to borrow. So when you borrow here, this is 0. How much is over here on your right? How many do you bring over?
2.
Okay,
One
some of
zero.
you, there are two ways of doing it. Some students use 2, but the actual way is to write there 10. Okay, so when you borrow your the 2 is actually, it is not 10, it is 1 0. Okay, the 2 is actually, because 1 plus 1 is 1 0. Okay, so when you bring this over, you're converting it to 1 plus 1, so it is 1 0. Okay, if you want to write that 2 also is okay. Okay, so 1 0 minus 1 is 1. So we have 0 here, still cannot minus. So we need to bring over. So this is 0 and this is 1 0. 1 0 minus 1 is 1. So we have 0 minus 0, 0, 1 minus 1, 0, 1 minus 0, 1 0 0 2. Okay, can? I think every other base number, it's quite clear. Only binary is because we usually confuse this 10 with decimal 10. Okay, when you do the normal when you do the normal decimal subtraction, when we carry over 10. Okay, here also we carry, it looks like we're carrying over 10, actually it's 1 0. Okay, this 10 here and this 10 here is not the same. Okay, this 1 0 is actually 1 plus 1 equals to 0. Okay, so that is the only confusion. So if you want to avoid confusion, you can also write 2 up here. When you carry is 2, it's okay to write 2 also lah. Okay, so that is for base 2. Okay, and then I'm just doing examples. I'm not doing for every base. Okay, so say you wanted to do for base 8. Okay, so we wanted to add these two numbers, 4712 plus 1624, base 8. Okay, so base 8, we know that we cannot write the answer in anything more than 8 or more. Okay, so we have to regroup when we reach 8. Yeah? So 2 plus 4 is 6. 6 is less than 8, no problem, we write it here. 1 plus 2, 3. 7 plus 6 is 13. Okay, so 13, that's more than 8, so we need to regroup. So 13, we know that 13 is 8 plus 5. Okay, so we have one group of 8. We carry up one group of 8, remainder 5. So here we have 4, 5, 6. Okay, okay. We have another example here, 4178 minus 2328. Okay, this is subtraction. Okay, subtraction, 7 minus 2, we can minus straight away, so it's 5. So 1 minus 3, we can't do that, we need to regroup. So we need to borrow 1 from here, so we have 3 here. When you borrow, you're borrowing this is place value is 64, right? So when you're borrowing 164. 164 is actually 8 groups of 8. So that's why we write here 8. Of course, straight away you can cut and write 8, but you must understand the concept behind it. Okay, you're actually borrowing 164, and 164 is written as 8 groups of 8. Since this is the 8's column, so we write here 8 only. Okay, so now 8 minus 3, 5 plus 1, 6. 3 minus 2, 1. Okay, so that's our answer. One more example, 7138 minus 314. Okay, so how do we do this? 3 cannot minus 4, so regroup. So what do we have here? 0. Here we have an 8. Okay, one group of 8 is 8 ones. Okay, so 8 minus 4, 4, 4 plus 3, 7. 0 cannot minus 1, we regroup again, so we have 6 here, and we have borrowed 8 groups of 8. Okay, so 8 minus 1, 7. 6 minus 3, 3. Okay, so if you can, so the process or the procedure of addition and subtraction is the same for all numbers. The procedure is the same. Okay, so only we have to know when we should regroup. Okay, so let's try this. Okay, see. Okay, let's try this as here. C9 to D, 16 minus 7, 16. Okay, so this is a hexadecimal numbers. Okay, so how do we do this? D is before E. Okay, so we know D cannot minus E because D is before E, so it is smaller than E. So we need to regroup. Okay, so we borrow 1 from this. We have 1 here. So when you borrow, you're actually borrowing 16. This is base 16, so you're borrowing 16. Okay, so 16 minus E. How much is E?
14.
Yes, 16 minus 14 is 2. So D plus 2 is D, E, F. Okay, D plus 1 is E, E plus 1 is F. Okay, so we have F here. So now 1 cannot minus 9. You have to regroup here. So you have 8 here and you have another 16 here. So 16 minus 9 is 7 and 1, 8. Okay. So here we have 8 minus F. 8 cannot minus F. Okay. So we need to regroup. C, when you minus 1, it becomes B. Okay. C minus 1 becomes B. Or you can think C is 12. 12 minus 1 becomes 11. 11 is B. Okay. So here you have a 16. Okay. 16 minus F. F is 16. So 16 minus 16 is 8. Sorry, 16 minus 16 is 0 and you have an 8 there. Am I right here?
F is 15.
F is 15. Oh, sorry. Okay. F is 16 minus 15. 1. 1 plus 8 is 9. Okay. So B minus 7. B is 11. 11 minus 7 is 4. Okay. So only the hexadecimal is not really difficult, but it's just that you have to be a little bit careful. Okay. Okay, let's just try one more for hexadecimal. Um, okay, so C is smaller than F. Okay, C is earlier than F in the alphabet system. So C is smaller, so cannot minus. So we need to borrow. So A is 10, we know. So what is left behind is 9. So when borrow over, we have 16. 16 minus 15 is 1. So C plus 1 is D. Okay, C and 1 more is D. Okay, C and 1 more is D. So we have 9 minus 6 is 3. 7 cannot minus B, so we need to borrow here. E, reduce E by 1, we get D. Okay, so we have borrowed 16 here. 16 minus B. B is 11. 16 minus 11 is 5. 5 and 7 is 12. Okay, so 12 is C. So we can't write here 12, so we have to write C. Okay, all single digits here. D minus 8. So D is 13. 13 minus 8 is 5. Okay. Okay, one last question that I want to do is for addition. Okay, hexadecimal numbers addition. B49C 16 plus 4E2F. Okay, 16. Addition, okay. C plus F. Okay, what is this? C plus F. F is already 15. 15, 15 plus C is 12. So what do we get? Or you know that F is 15, right? So you take 1 from C and you give it to F, so it becomes one group of 16. So we carry up one group. C reduce 1 becomes B. Okay. If you cannot do that way, you do it like this. Okay. C is 12 plus F is 15, which is 27. Okay. 27 is actually 16 plus 11. So you have B and carry up 1. Okay. Then second column, 9, 10, 11, 12. 12 is C. 4 plus E. E is 14. 14 plus 4 is 18. 18 means you have 2 here. Regroup 116. Okay. Then you have B plus 1. B is 11 plus 1, 12. 12 plus 4 is 16. Okay. So you can't write 16. You write 0. You carry 1. 1. So this is the answer. Correct?
Excuse me, madam.
Yes.
This question I can't understand, madam. How
Which
come
one?
this 9 plus 2?
Or how this 9 plus 2 is C, yeah?
Ah,
Okay. when you start doing, it is good if you have the number system next to you so you can check the value of the digits. Okay, this one you have no problem. C plus F. You can write it down like this and you can do. You know that is 116 and 111. Or I know that F is 15. Okay, I know that F is 15. I need one more to become 16. So I take one from the C to become 16. I regroup one here. So 16, C minus 1. Minus 1 means one place before C is B. So I write here B. Okay. So now I have 9, all numbers here. Second column, all numbers. 9, 10, 11, 12. Okay. So in this base 16 number, the symbol for 12 is C. So I replace 12 with C because I cannot write, when I add 12, I cannot write 2 carry up 1, cannot. That is base decimal base. Okay, decimal base means I write 2 carry up 1. But this is base 16. That means I can add until 16. I can write until 16 in this place. Okay, so 9, 10, 11, 12. I can actually write 12. But I cannot write 2 digits here. I must write a symbol here. So the symbol for 12 is C. Okay, and then the third column, E plus 4. E, we know is 14. 14 plus 4 is 18. So I can only write up to 16 here. Okay, so 18 minus 16 is 2. That means 2 here. This one group, I regroup up here. Okay, so B is 11. 11, 12, 16. I have 16 here. So I cannot write 16 because I have to regroup. Okay, so 16 minus 16 is 0. No remainder, no remainder. This one regroup up here. Okay, so I have 1 here. Okay.
So in base 16, 1 is equals to 16, madam.
Yes. It's not 1 is equal to 16. Base 16 means you regroup every 16. Base 14 means you regroup every 14. Okay. Base 10, we regroup every 10, right?
Yeah.
We cannot write 10. Once we reach 10, we have to regroup. Same like that. Base 16 means you have to regroup by 16. Base 15, you must regroup at 15. Okay. So if you have a number like this, 21, in base 10, what does this number represent? It represents 2 tens like this, right? 2 tens and 1 ones. This is 21. And this one we divide into 10 equal parts here. But 21 in 16, in base 16 means 2 16ths and 1 unit. And this 16 here we divide into 16 parts here. Here we have 16 parts. Here we only have 10 parts. That's the difference. Okay. So here we regroup every 10. Here we regroup every 16. Okay. Base 16 numbers are known as hexadecimal numbers. The only difference is that we have alphabets to represent digits more than 9. That's why when we do the addition and the subtraction, it's a little bit confusing. That's all. Okay. Other than that, the procedure is exactly the same as decimal numbers. Okay, any other questions? Any other questions, class? Sorry.
No, madam.
So you understand, so today we're only looking at the types of base numbers and the symbols only, okay? So next week we will be doing conversion, okay? So base 2 numbers are also known as, what do you call base 2 numbers?
Binary.
Binary. Base 3? Base 2 is binary, yeah? Base 3? Ternary. Okay, base 4, if you don't know this also is all right. Okay,
Quaternary.
quaternary, and base 5 is quinary. And base 6 is quinary. Yeah? Base 6 is what is base 6? Scenery, I think it's called scenery. Base 7 Septernary, base 8. This you must know, octal. This is very important, okay? Base 8 is octal. The rest are not necessary, lah, okay? Nonary, base 10 is our decimal system, okay? This is our own system here, okay? And then base 11 is also known as, what do you call base? Undecimal. Undecimal. Base 12 is known as duodecimal. Okay, the rest I'm not sure already, but base 16 is hexadecimal. Okay, this is very important. This is very important. This is very important. These three are this base 2, base 8, and base 16 are very important because it's very easy to convert from one to another, and we use this quite a lot in the digital systems. Okay, so that's why these three systems are very important, more important than the others. Okay, what else? Digits in base 2, 0 and 1, also known as bits. Okay, they're known as bits. And one more thing that you must know is if you have a number like this, say you have a number, this is base 2 number, this last digit here on your right hand side, the last digit on your right hand side is known as the least significant bit, or for other numbers is least significant digit. We call it the LSB or LSD. Okay, the number on the left is known as the most significant bit. Most significant bit or digit. Okay, it is the MSB or MSD. Okay, this you will need to know later when you convert, when you use shorthand methods to convert. You need to know which is the least significant bit and which is the most significant bit. Least significant bit is the number on the rightmost, and the number on the leftmost is the most significant bit. Okay. Okay, I think for today that is all you need to know. Okay,